we are recording this event. So once you see a video on YouTube saying and showing this title slide, this is the webinar we were having today, and you can share it with your friends, view it later, and also save it for future reference. Also, we've got a questions and answers box in GoToMeeting control panel, so you can ask any questions you may have using this questions and answers box. And before we start, I would just like to quickly go through the audio and video quality. So please use the questions and answers panel to submit brief feedback about audio and video quality you are getting. Okay, great. Thanks for the feedback. Just in case, if you are dialing in and the audio becomes choppy, you can redial in again using a different number. That usually helps. Normally we don't get any issues, but just in case it happens, be aware. Right. So let's get down to our agenda for today. We'll talk about our history, how we came to virtualization and how we came to storage issues in virtualization. Then we'll get into a bit more detail on IO Blender. What is it and why it affects storage performance so much. Then we'll see how we can overcome IO Blender. And of course, we'll see how we can eliminate it completely. And in the end, we'll have a questions and answers session. I'll gladly answer all your technical questions on the log structured file system, or about StarWind, about our appliances, or any virtualization related questions you have. Now, a while ago, I think maybe 10, 15 years, no one really used virtualization. We had piles of servers sitting in our data centers, and everything worked great except of our resources, which were not really utilized intensively. So we had, let's say, 10 servers, but each of them was only utilized for 20, 30%, sometimes 50, but no one really got effective resource utilization those days. So one server is running one application, and there is no way to be flexible in that kind of environment because the cluster is a cluster. It has two hosts, it runs one application inside, and there is no way to be flexible, like let's say add applications without paying, and there was no way to manage it from one place and manage all your applications, see how much resources they consume. With virtualization, however, this thing luckily has changed. Our even single server can run now multiple applications. We've got almost 99% resource utilization with multiple applications being consolidated within one host. Something we see today in most data centers, something which derives into virtual machines, virtual desktops, and containers will be seeing in the next releases of all major hypervisors. And of course, with virtualization, we get much more effective storage management because we don't have aisles of storage anymore. We've got a single resource pool which is used for all applications to work. And of course, we have simple management. We get into a console and we can see all our applications, all our virtual machines, all our virtual clusters in one place. We can control everything. Networking is virtual, so you really never go to the data center to reconnect something or reroute something. You can do that from one management console sitting with an iPad and drinking cocktails in the middle of nowhere, or let's say on an island on a beach, wherever you are. So the management got that simple. I've tried it once, I will never go back, and I really recommend everyone who is not into virtualization yet try it. It's definitely worth it. However, with the virtualization, there is one problem which emerged, and it was a really big issue, and it is an issue these days as well. However, we have the solutions. So this webinar about the solutions to storage problems in virtualization. Multiple applications do a huge hit on the storage. Even if we have a big RAID 10 array with all 15K SAS, so the fastest spinning drives you can get, it really starts crawling when all applications access one array at the same time. So if you could use that array at, let's say, 500, 600 megabytes per second, with streaming, you would never see such speeds with real world virtualization workload. So the effect of storage arrays, especially spinning ones, getting really slow in the virtualization environment is called IO Blender. So that was kind of a basic and nutshell explanation. So essentially what happens, we've got several virtual machines running different applications residing on one storage resource. And if these applications want to use their two areas of storage on the disk array, the underlying storage starts doing random writes and reads all the time because it needs to service multiple applications and it needs to get all the data from the entire drive almost instantly to all the applications to maintain the good service level, to maintain good latency, so your SQL bases can work fine, so your Exchange works fine, and your file server works fine. So all these loads are now consolidated on one disk, and it becomes a real issue to performance. You may see it as your applications being slow in the middle of a day, or your virtual desktop sometime being slow when you log in the morning. So these are the things end user sees because of IO Blender. So what shall we do with IO Blender? How can we overcome it? How can we address that issue in virtualization world? Basically, there are certain workarounds. Like, let's say we've got some typical workloads which are separated into groups, and we can simply deploy one RAID group per this typical load. However, this introduces a problem we had a while ago with non-virtualized environments. We now have islands of resources, and we cannot really move our applications between these resources flexibly and non-disruptively. So that's a big issue. We've got virtualization for flexibility. Now we are giving up flexibility for performance. That's not how it should be, at least in my opinion. A second solution may be deploying all-flash storage for your virtualization systems. That is a really easy solution to IO Blender issue because Flash is fast, it's extremely fast, and doesn't know anything about random access problems like the spindles. The spindles just fail, they'll start crunching and give you 1,000 IOPS instead of 20,000 IOPS, where 20,000 would be preferred, of course. But the issue with all-flash storage is even though the SSDs get cheaper and cheaper, it's still really expensive. There are certain vendors who provide really sweet pricing, like $400 per terabyte of SSD, but that's just a few vendors, and you won't find these prices anywhere on the enterprise server market. So it's something like go support yourself solution, which is not kind of thing we're looking for in a virtualization world, especially if we want to put our business on such a solution. And a third solution for overcoming IO Blender would be implementing storage, which knows about IO Blender and knows how to deal with it. I would just call it a VM-centric file system or a VM-centric storage solution. So what would be a VM-centric storage solution? The main idea, I would just use StarWind as an example with StarWind's log structuring technology. We got IO from applications coming down to storage, and inside the storage layer, StarWind has 3 levels of media where it stores data. Now, don't be deceived. It's not just like tiering, so not putting hot data on RAM and then on flash and then on spindle. There is actually a more intelligent approach to that. So first, IO stream is buffered in RAM. Then in RAM, StarWind uses deduplication to get rid of similar blocks and identical blocks. So it reduces the amount of data to be actually written to the disk. In parallel, the data about deduplicated blocks is written into a separate deduplication log, so we know where to get that data from because there is no redundant block anymore. It's all stored in one place. After that, StarWind consolidates all these small writes into a huge block and then writes these blocks to the underlying storage. And the key to eliminating the IO Blender is to write all these blocks sequentially. So we never use our underlying spinning storage randomly and thus get streaming speeds instead of random IO speeds, which are by order of magnitude better. So this is how StarWind deals with IO Blender. This is not a unique solution in the storage world. However, it is a unique solution in the software storage world. So there are no other solutions which do full log structuring in a virtual SAN world. You may see these technologies in companies like NetApp or Nimble with their technologies NetApp Waffle or Nimble Castle, which essentially do the same using proprietary hardware like DRAM cards and flash used for consolidating data before the data goes to spindles. But if you want a virtual one, StarWind by far, I guess, is the only possible answer. So what does this bring us in a virtualization environment? What was before and what we can use now for virtualization to get top-notch performance from seemingly slow storage. So yeah, we got rid of that blender here. First, with the StarWind LSFS, you'll get certain storage miracles. You would never imagine a RAID 5, which is banished in all storage communities now working in virtualization. All parity RAIDs get banished there. So 5, 6, 50, or 60. They typically literally crawl under virtualization workloads. And if a drive fails, you can say goodbye to your production environment. However, with StarWind's log structuring, RAID 5 or RAID 6 or its derivatives work better than a RAID 10 would do in a typical virtualization environment. So let's say if you have 6 10K SAS drives, if you put them in a RAID 10, that RAID 10 would be slower than a RAID 5 comprised of the same number of drives and StarWind's log structuring file system used on top. Then nearline SAS RAIDs show more IOPS then 10K SAS, and sometimes then a SSD array. This is all because we have streaming speed instead of random speed characteristic of our array working if we go with the log structured file system. Then if we try to apply this technology to an all-flash array, we also get certain benefits. First of all, our SSDs live longer because we do full read writes of big blocks. We never do read, modify, write cycles to the hardware. We only do write, then mark blocks as clean, and then write there again. So we never remove data from there to rewrite it with other data. So this also results in a side effect which is really useful for SSDs, which is getting rid of spot burns. If you have a really hungry application, like let's say SQL database sitting on an all-flash array, certain areas will get overwritten much more often than the other, let's say, area of the flash array. So these cells will wear out faster, which can result in a premature array failure and necessity to replace the SSD, which is not really a good scenario in a storage world. Then, in typical environment, when you do snapshots, you lose some of the performance because with every snapshot, you either have to do a copy on write, so all the new data which you want to get into a snapshot is copied when writing, so you double the I/O on the array, which causes a performance penalty. Or you can do redirect on write, so all new data is now written to a different spot on the storage. So with a traditional storage approach, that would cause a huge performance penalty because now your virtual machines are scattered across the drive and there is no single area where the entire virtual machine sits. So now we have a base, we have one snapshot, second snapshot, third snapshot, and the data is located in random places, which increases the random load, the random nature of the load of the applications working in the virtual machines. With log structured file system, since we always do sequential workload and we always do large blocks, every snapshot can do redirect on write with absolutely no performance penalty. So you said you want a snapshot, StarWind says okay, and simply continues writing, marking the next block it writes as a beginning of that snapshot. So that's an easy solution to the performance issues with snapshots in a virtualization environment and in shared storage environment in general. And one more good thing about having the log structured file system and doing some of the operations in RAM is inline deduplication doesn't cause any overhead with StarWind's log structured file system. Let's say you have standard Windows deduplication and you have StarWind's inline deduplication. So the mechanisms are seemingly the same for the end user. You write some data and then this data at the end consumes less space because redundant blocks are removed. But with Microsoft, the data is first written fully hydrated to the disk. So let's say you've written a terabyte of email base to your disk. It first consumes a terabyte and only then Microsoft scans it and deduplicates it. With StarWind, that deduplication happens the moment you write it to the disk. So at the moment when you've written the data, it may be, let's say, 200 gigabyte instead of a terabyte, which is much less impact on the storage array. And also, when this data needs to be fetched again for reads, most of that data, because it's deduplicated and it occupies much less space, is available in the RAM cache. So we don't fetch the data from the disk now, we fetch it from RAM, which is much faster compared to just working with spinning disk storage. Now, you may be wondering what would be the typical use cases for StarWind's log structured file system. Log structured file system is not a remedy for all virtualization environments. There are certain use cases where it shines, and there are certain no-goes where you would rather want to implement a traditional file system which doesn't do log structuring, and where these benefits don't shine that much. So virtualization in general would be the use case. However, I would narrow it down to virtualization environments which are write intensive. If your environment has a lot of random writes, that's the place where you want to implement StarWind's log structured file system. With random writes removed, the performance goes sky high, and with inline dedupe, the amount of data we keep in the cache is much higher. But in a read-intensive environment, we see the downside of the log-structured file system, and it's not something you would only see with StarWind. That's just a general, I would say, peculiarity of the layout with log-structured file systems, with any of them, be it a partially log-structured or fully log-structured system. When you write the data in huge blocks, sequential only, naturally the reads get randomized. So if your environment is mostly read, and let's say you have a lot of databases where you write certain amount of files a day, but then at some point you need to read them a lot, like rescanning, doing reporting and stuff like that, the read IO gets really random. So StarWind's log structured file system addresses that by using Flash as read cache. That may be a surprise for you, or that may sound strange because a lot of vendors advertise we've got Flash write caching. But here's the thing: why do you really need Flash write cache if your underlying spinning storage array performs with streaming speeds in a virtualization workload scenario? If you can get 30 to 4000 IOPS from a SATA RAID 5, why would you spend money on a lot of write-intensive SSDs to put write flash on it? Instead, you just use commodity read-intensive SSDs, which are both cheaper and more durable in this scenario for accelerating reads. In this case, every storage layer works for a purpose. Underlying spinning disk works for streaming writes, where it shines. Flash shines at random reads, so it does random reads. And RAM shines for all I/O application, but it's not yet there to be the only storage layer, so it works as primary write cache and deduplication log storage. Then, I already mentioned it's for write-intensive environments, and one more scenario where the log-structured file systems shine is the virtual desktop environments. Because of inline deduplication and because of log structuring and because of combination of being write-intensive, which most virtual desktop environments are. Just for a reference, the typical read-write distribution in VDI environments is 80% write and 20% read, and 90% of that IO is almost full random. So this is the environment where you want to implement log structured file system. This is the environment where you'll see all the benefits, where you'll see that 100 virtual desktops actually occupy as much space as 10 virtual desktops would do, and that most of the data processed throughout the day is pinpointed to flash cache and RAM cache of the device and is not really going down to spindles. So that keeps the spindles cool, and that keeps flash and RAM busy, and that keeps your customers happy. At the end of the day, that's the ultimate solution we seek. We don't seek like top-notch performance. We don't seek consolidation snapshots and stuff like that. We seek good customer experience for users who are working with the virtualization environment we architects build, and we just want them to be happy, and we want, if something goes wrong, to be able to restore everything fast and smooth, or if it breaks in the middle of the night, we just want to get a text saying that StarWind high availability worked just fine, it failed over. Once you come in the morning, just purchase a new drive because one failed in the server. And that was all for the presentation. I'm now open for all questions. I see there are a lot of questions in the questions and answers panel. Let me just expand it a little bit so I can read all of them, and I'll just go through them one by one. Okay. Yeah, the gentleman who asked the question just left, so I'm not sure we need to address it. Okay, the question from Michael. Do you see a need for RAID arrays with StarWind vSAN, or would the design work adequately without RAID arrays using JBOD? RAID arrays are still preferred for parity and for resilience. So we can still use JBODs and then attach them to a local RAID array, but I wouldn't say I am ready for deploying a production environment on something software like storage spaces. We've tested the performance. We didn't really see an improvement compared to a hardware RAID. So for now, I'm optimistic about the developments, but I would say it's almost time to move there, but we need to wait maybe half a year, and we should start considering using JBOD instead of local RAID arrays. Then a question from Ulrich. Can we get the recording of this presentation? Indeed, there will be a recording available as soon as we finish this webinar. Every attendee will get a follow-up email with a recording link on YouTube, and you can also subscribe to our YouTube channel, and you can also get StarWind trial on our website and see how fast the log structured file system works. So just put some virtual machines on top, see how it deduplicates them, see how fast they're working, and see where you can implement this, because there are a lot of sweet use cases in every virtualization environment for a solution like that. Then one more question from Michael. When looking at RAM caching and flash caching, do you offer specific ratios to offer the best performance? Now, with the log structured file system, we tend to do 10% of the usable capacity covered by flash, and RAM caching really depends. Usually it is sufficient to do 1 GB per terabyte of storage. However, we've proved their smaller numbers also work fine. Essentially, since we do streaming sequential write in the storage layer, on the actual spinning disk layer, RAM caching can be shrunk down to, I think, 128 megs per terabyte of storage. Okay, question from Lonnie. Is this log structuring system part of the standard StarWind license or an add-on? This is the part of a StarWind standard license. It will also soon be available in StarWind appliances. We started shipping last May, so you'll see more of those appearing. But if you are a current customer, and I see there are a lot of current StarWind customers on this webinar, you can use the log structured file system in the StarWind build. And of course, for best user experience, since we're all in the digital era where every bug or every new feature is added in a blink of an eye with a system update or a software update, make sure that you get the last StarWind version. The latest software version always assures best user experience. So that would be my recommendation for everyone who wants to try the software. Okay, a question from Sokum. Regarding your website, where does your software sit between hypervisor and hardware? So how do I install the software, or is this something that your company does? StarWind is installed on Windows in the parent partition. If you use Hyper-V, if you use vSphere, StarWind is distributed as a virtual storage appliance. So it's the same Windows, it's installed on Windows, but in this case, it's inside a virtual machine. Then a question I really like from Lonnie: how many IAPS can this technology provide? I tend to answer all of them because we pushed the hardware RAID arrays to the limit with LSFS. So we tried RAID 5 with standard file system. We got something like 700 IAPS for 4 kilobyte random write. With StarWind's log structured file system, we got approximately 36,000 IAPS out of the same RAID array for the same write pattern. So 4K random write, 37,000 IAPS, SATA RAID 5 array of 6 drives. May sound fantastic, but that's the reality. Okay. Question from Douglas. Can I repurpose my iSCSI QNAP as backend storage for StarWind Virtual SAN? Yes, this is possible. You will need to consult with our engineers for best practices on backend iSCSI arrays. We see a lot of people using QNAPs, Buffaloes, and sometimes even Synologies used as backend storage for StarWind. So just make sure that you follow our best practices and engineers' recommendations when doing that. Question from Sam. How is the write caching fully non-volatile? This is done by mirroring the cache between participating cluster nodes. So when we receive a block, we first mirror it between the nodes in RAM, and only then respond that the block is acknowledged as written. And given the fact systems are on UPS, if power fails, one system shuts down immediately, second system flushes the cache and then shuts down as well. In this case, no block is lost even if the power goes out. Okay. Then, yeah, several questions about RAM caching I already answered. And let's see. A question from Lonnie. 37,000 IAPS on SATA RAID 5 is nice. Did you do an IAPS measurement with 15K SAS drives on RAID 5? Unfortunately not. The primary interest is to resurrect RAID 5 and SATA as primary storage. So I would say that the performance improvement would be linear to 15K SAS as well. So let's say if you got 1500 IAPS of a SAS RAID 5, I would expect something like up to 60, 70, or even 90,000 IAPS with log structuring technology. Essentially, you can benchmark it easily by just putting 4 megabyte sequential write on a 15K SAS RAID 5. That would be approximately the same which StarWind, approximately the speed which StarWind can get you with the log structuring technology. And let's see. Yeah, so it looks like these were all questions. No, a few more questions. You are saying the demo includes the log structured file system. Indeed, you got the link on the screen. You can download StarWind Virtual SAN, install it on your servers, and this demo already includes the log structured file system capability. So you can select that option when creating the storage device within StarWind. Question from Michael. Does the IOPS performance scale linearly when adding more drives to an array? Instead of 6 drive SATA array, we would use a 12 drive array. I would say almost linearly because the RAID nature itself, it doesn't scale linearly, but I would say that with those numbers, you would see almost straight line on the graph when growing from 6 drive to 12 drives. Question from Victor. Ethernet card should be 10 gigabit or 1 gigabit is good too. 1 gigabit is sufficient for applications and environments which do not exceed 30 or I would say 28,000 IOPS. So everything higher than 28,000 IOPS, I would consider going 10 gigabit, especially given the fact that 10 gigabit networking became so cheap and so affordable. Then getting a dual port 10 gigabit card is cheaper than getting a 1 gigabit quad port card. And also, that's a shameless advertising, but a lot of our customers, as well as myself, got 10 gigabit unmanaged switch from Netgear, which really shine in iSCSI environments where you don't really need to manage the traffic that much. Question from Michael. Is there any advantage to using 10K or 15K drives when using StarWind vSAN? I wouldn't say there is advantage with using faster drives. So the idea is to use higher capacity drives and not faster drives. So in any case, with streaming speeds, you may hit the bus speed faster. So I don't think it makes sense to waste money on faster drives instead of getting higher capacity drives. And there is one more thing peculiar to log structured file system. If you go with full random workload, your data set may get a little higher than the actual nominal size. So let's say you have 1 terabyte of data which is accessed randomly all the time and constantly rewritten. With log structured file system, we sacrifice some of the capacity for performance. So it may get 1.5 terabyte if you overwrite it within hours or 2 hours. It will then shrink, but it uses certain amount of disk capacity as a buffer to maintain the performance level. So in this case, higher capacity and lower performance drives shine, and higher speed drives will also work good, but the space would be overused, which is a bigger impact compared to nearline SAS or SATA. Question from Douglas. We can use SSD read cache, RAM write cache, and LSFS simultaneously, correct? Yes, that is absolutely correct. I would start with just using the LSFS with RAM cache and then add the read cache once you figure out how much you need for your working set, because undersized or oversized read cache will not show you the best results. So it's a really good idea to figure out how much you need before implementing. Okay, and one more question from Michael. Are you saying that the overhead of LSFS can be up to 50%? Technically, it can be up to 100%, but that is only a technical limit where we write where we override the entire drive within 1 hour for 3 or 4 times. In this case, our 1 terabyte can grow up to almost 2 terabytes, but in reality that does never happen. So you only keep a certain overhead for LSFS to grow and shrink, but you never do that over provisioning and you never get that type of workload in real life. Okay, so I guess these were all questions for today. Should you have any more questions, I'll gladly answer them. Just drop them to the email addresses listed on the screen or to max@starwind.com, and I'll gladly help you out. I would like to thank everyone for attending our today's event. I hope it was interesting for you, and stay tuned for updates from StarWind and for some Christmas surprises. Wish everyone a great day. Bye-bye.